Hello. So we decided to take a paper about debt trunk, and the paper is discussing about the fact that are some institutions too central to fail, and they discuss about the financial networks, the Fed, and also the systemic risk. The article was written by Battiston, Tuliga, Kaushik, Tasca, and Calderelli. So first we'll go through an introduction. So the data set used in this paper is coming from the Fed, and the Fed gave $1.2 trillion to institution in order to avoid bankruptcy. A lot of institutions received the money, but among them 22 received the most. Also, the paper will discuss about the fact that you have to take also into account the too central to fail concept and not only the too big to fail. The paper will discuss also about the fact that after the economic shakeups, there were a lot of people that were aware about the importance of the financial system and the fact that it should be considered as a complex network where you have nodes, those are the financial institutions, and then you have links, those are the financial dependencies. Systemic risk, systemic financial institutions are the ones that, if they go bankrupt, they will trigger a systemic default and they are considered, therefore, as too big to fail. And the too central to fail concept is a concept where you have nodes, as I said, and links, and where it's like a domino. If one go bankrupt, it can get the others to bankruptcy. So basically, the main goal of the paper, and they said it, and that's written in the paper, is to show how network science can contribute to a quantitative assessment of a systemic risk. So there are two main concepts in this sentence. First, the network science. We'll talk about nodes, we'll talk about links, and also about debt chunks, and also the systemic risk. Those are the two main components of the goal of the paper. Then, what are the contributions of the paper? So basically, the paper is divided in four parts for the results. So first, they analyze the portfolio of loans that were granted by the Fed, and it was analyzed over the time and in terms of concentration and also fragility. Then they analyze the distribution of outstanding debt across institution and also time. Then they investigate the structure of a network, dependencies among funded institutions. So then we'll talk about nodes and links. And the last one, they introduced a new measure, which is the debt rank. This is a measure that estimates the systemic importance of the various institutions.
Some authors have to talk about the financial network and systemic risks, such as Schweitzer F. al. in 2009, which is speak about the characterization of the economic and of the architecture of economic and the financial network. We have also Gelfeder, TB, and Batson in 2011 who wrote an article about financial system showing that financial system is a complex network represented by the node and link. And we have also Haldan and De Massey and Batson S.A. in 2009, 2010, and 2012 who have wrote in the systemic risk showing that the financial system is measured by the analysis of the dynamic evolution of the node and the structure of network. Finally, we have Slotin Barabatsi in 2011 has shown that too big to fail is related to the general issue of the controllability of a complex network, and Saramaki and Kant et al. Showing that scarcity of data have limited the study to few national datasets. Now I'm going to talk about the results of paper. The first result is the credit concentration and fragility. As a measure of concentration of the credit portfolio, we compute the half-final index of the outstanding debt. The fragility is measured by the weighted average, which reflected the fragility of the largest borrower. The second is the debt distribution. To improve the statistic, we pull the value of debt over interval of 30 days after checking for the homogeneity of the debt time series within those intervals. The third is the network analysis. In the network perspective, note represent institution while the direct edge represent lending relation weighted by the amount of the outstanding debt. Finally, we have debt run and systemically important institution. In order to estimate the impact of the note on the order, we then introduce debt run as a novel measure inspired by FIPAT centrality. The credit concentration and fragility. We start our analysis of the dataset from the sum of the outstanding debt across institutions, which represent the total exposure of the Federal Reserve, such as the total potential loss in case of default of the borrower. As a measure of concentration of the credit portfolio, we compute the half-final index ratio of the outstanding debt. As shown in figure 1, hash remain around 0.05, meaning that despite the large variation in the size of the exposure, the number of leading borrowers remain approximately around 20. Plot over time of the total exposure of the Federal Reserve represented by the curve in blue, and of half-final index hash of the Federal Reserve credit portfolio represented by the curve in red. The effective number of borrowers is given by the reciprocal of hash, which vary between 10 and 30. The weighted average of the fragility, which reflected the fragility of the largest borrower, displayed peak in corresponding to the major event, such as the Gestion case in March of 2008, and the drop in stock market value as of March in 2009 in figure 1b. Plot over time of the total exposure of the Federal Reserve in blue, and of fragility the Federal Reserve credit portfolio in red. The peak correspond to major distress events such as the risques of the Stern in March of 2008. Note that in this picture we remove a big peak in fragility caused by the stock of the Lehman and Brothers default. Remarkably, when the total exposure of the Federal Reserve still amounted to 900 billion, the debt of the leading borrower was more than 6 times larger than their market capitalization. Now, we talk about debt distribution. The dataset provides a unique opportunity to study the distribution of the outstanding debt across institutions and across time. Based on the behavior of the total federal exposure, we divided the time span of the data into 3 phases. One, the beginning of the crisis from August 2007 until April 2008, where the Federal Reserve exposure is in below 20 billion of USD. 2. Plateau, April 2008 till October 2008, where the exposure raised and stay around 380 billion for 3 months. 3. Peak and decline, October 2008 until April 2010, where the exposure peaked in a short span of time and start to decline at a slower rate due to a parallel toxic assets purchasing program. For each period, debt value across day were pulled together in order to increase the statistic. Then, To improve the statistic, we pull the value of debt over interval of 30 days after checking for the homogeneity of the debt time series within those intervals. For each distribution, the value of the debt are rescaled by the total debt across institutions in that period. Note that distribution within the same path look similar. The debt of the top 100 institutions by average debt is represented as a topographic map where the color indicates the debt of each institution as a percentage of its own maximal debt, from green to yellow to red, representatively 0 over the 30%, 30 over 70%, and 70 over 100%. Statistical tests suggest that their parameters are more similar within the same market path. This can be seen also in figure 2a, where the curve in blue and violet cluster together. An explanation of the scaling behavior would be that at each point in time, the Federal Reserve lends to all institutions in the same proportion, and that only the total amount varies. In figure 2, we find that although about 30 institutions reach their respective peak of debt in the same period, many others had their peak few months earlier or later. Moreover, while some institutions the debt declined rapidly, for others it declined slowly. Uh, uh, the similarity of the debt distribution seems to be an emerging program of few systems.
So now we'll discuss about the network analysis. So as you can see, in A you have the case before the crisis, and in B it's after the crisis. So you can see nodes, which are institutions, and also links. As we said, these are the lending relation weighted by the amount of the outstanding debt. So as you can see, there are a lot of dependencies inside the network analysis. It's due to the fact that each companies can invest into others one, and some previous work has shown that the equity investment network of TNC, which is a transnational corporation, has a bow tie structure with financial firm in the core forming a tightly connected structure. You can also see that there are 22 institutions inside of that, and they receive for 67% of the total amount given by the Fed. So they received 800 billion out of 1.2 trillion dollars. And over the 10 periods, they received for each companies more than 5 billion. In the core of the TNC, you can see that the edges are highly connected, and the institution can reach one another to a direct path. For 99.1% of the case, the companies can reach each other from one or to two direct paths. So you can see that the structure is quite homogeneous with a high density of connection. If you compare it statistically, you can see that the in and the out degree is the same, and it's 12.1. This means that each edge is touched by 12 other nodes. Also, if you compare it with the K-core, you can see that for most of them it's 8, but only for 3 of them it's less than 8, and this means that the average is 7.7. So this means that everyone on the network has at least on average 7.7 connection. You can also see that after the crisis the centrality is really high. You can see that most of the companies are really in the center. This means that if one company goes bankrupt, it could lead the others to a bankruptcy also. And you can see that the bubbles has changed color So you have now green, yellow, and red one. The red one are the most dangerous. So now we'll discuss about debt rank and systemically important institution. So first of all, and as we said previously, debt rank measure the systemic importance for institution. This takes into account the impact of a distress of an initial node across the whole network. This part is highly related to the previous part, which was about the network analysis. Indeed, if you have a high value, for instance, of a debt rank, this means that you're located in the center of the network analysis, and this means that debt rank and centrality are used by the authors as the same word. So whether you use debt rank or centrality is pretty much the same. So it's the same as the previous one. You have A before the crisis and in B after the crisis. You have also the measure of the debt rank and the relative asset size. You also have the fragility, which is constructed by the bubbles and the size of them, and also the color. So the darker you are, the more fragile you are, and the bigger your bubble size is, the more you have outstanding debt. So you can see that before the crisis, it was quite homogeneous, and you have all the institutions pretty much in the same area. You have, except for 3 of them, everybody is in the below the 4.15% of debt rank. You have BOA, GPM, and Citigroup that are above, but still they are under the 0.25 debt rank. You can see also the size of the bubble is really small, and if you see like BOA or JPM, it's really small, and the biggest one are Dexia and Natixis. You can also see, if you compare it with the color, that it's yellowish and it's going a bit in the orange, but not that much. So the color are not dark. This means that the institutions are not fragile. And you can also see that institutions such as UBS or Citigroup represents almost 10% of the whole asset size. Now, if you compare it with post-crisis time, you can see that it's all changed and it's more heterogeneous because you have institutions all across the graph. You can see that first of all, the size of the bubble has increased. You can see, for instance, that UBS or RBS are the hugest one. You can also see that the color has changed. You have less and less yellowish institution. You have sometimes some really dark ones, such as Fortis, and you have a lot of really red ones, such as Dexia or Wachovia or Barclays. So this means that the fragility of the institution has gone up and a lot. If you compare also with the asset size, you can see that most of them moved on the right side. So this means that the relative asset size increased. And if you have a look at the debt rank, you can see that most of them has gone up also. And it's not that much homogeneous that it was in the case before. So you can see that for 12 out of 20 institutions, they are over the 0.5 debt rank. And you can also see that 6 out of 22 are over 0.7. So this means that 6 out of 22 companies can affect 70% or more of the institution. And this leads to a high centrality and a high fragility also. And as I said, the size bubble has increased, which means that the proportional to outstanding debt of institution has gone up.
Now I'm going to talk about methodology. Data. Data consists of daily time series of outstanding debt and market capitalization of 405 institutions in a period of 1004, the spanning from August 2007 to June 2010. Outstanding debt of Outstanding debt refer her to the amount owed by an institution to the Federal Reserve as a result of the emergency loan granted by the Federal Reserve via the so-called discount window and various emergency program. This means that these were loans for which the Federal Reserve was lender of last resort. Credit concentration portfolio. The Herfindahl index is a common measure of size concentration. In our context, we define it as the formula in the left, where DET denotes the outstanding debt of borrower I at time T. When the debt is equally distributed among n institutions, hash is equal to 1 over n. In contrast, when all the institutions except one have zero debt, then hash is equal to 1. Thus, the inverse of hash is a measure of the number of leading borrowers. The higher the debt relative to the market capitalization of an institution, the weaker is the institution, financially speaking. Thus, the following weighted average given then a measure of fragility of the entire Federal Reserve credit portfolio. The debt weighted average ensures that the fragility of the institution with larger debt counts more.
So now, what are the limits of the paper? So the first limit is that there is a lack of transparency for the data. So, for instance, to use some data, they had to use the proxy. So this means that the precision has gone down, and also the Fed didn't give all the information, so they had to make up this lack of information and to find some other documents, and also to use some proxy, as I said, to replace the information that was needed. Then the second one is related to the concentration one. Indeed, to calculate the concentration, they had to use the debt-to-equity ratio. But one of the limits of the debt-to-equity ratio is that it focuses on the amount of borrowing and not company's ability to actually service its debt. So those are the two main limits that the paper is going through. So now we'll go through a conclusion, and we'll take all the main elements of the paper. So the first one, as we saw, with the debt distribution and the concentration, we saw that the number of leading borrowers varied between 10 and 30. It was pretty much the case for 22, but it varies between 10 and 30 over time. Then, the fragility of the portfolio moves with the major events. As we say, 2008 marked a huge move for the portfolio. Then, if we have a look at the distribution of debt, we saw that it had the same functional form over the time. Also, there was an introduction of a new measure, which was the debt trend, and this helped to use it with the network analysis and to see that there were nodes and also links and dependencies between the institutions. So the question is, are some institutions too central to fail? As we saw in the report, we can say that it's a major key to take into account, because we have the too big to fail, but it's not enough, and we have to take into account the too central to fail in order to be complete with with the paper. So too central to fail is highly related to network analysis and also to debt trend. And this showed that some companies are really central, and if they fail, so if they go bankrupt, they can take some other one in the bankruptcy. So it's like a domino. And yes, some companies are too central to fail, and this needs to be taken into account. Thank you.